Clean architecture is one of the best ways to structure your app. It provides a great foundation for a code base that is easy to maintain and test. What exactly is clean architecture? It's a way of breaking your code base into layers. The inner layers are the core of your app. They contain use cases and entities. The outer layers contain the UI, database access, and infrastructure-related items. In this video, we will explore clean architecture by building a web API for an invoicing app. The process starts with the domain layer. First thing, let's create a new class library project. The name is invoicing.domain. In this project, we're going to define entities. These are real-world concepts like invoice, invoice item, customer, etc. These C# objects contain not only business data, but also business logic. To promote reuse and testing, keep this project free of external libraries or frameworks. Entities alone aren't useful. Let's build something on top of them. That's where the application layer comes in. In this new project, we define what actions we can perform within our system. It's things like creating an invoice, retrieving a list of invoices, marking an invoice as paid, and so on. We call these actions use cases. We will handle these actions using commands and queries. A command is a request to perform an action. A query is a request for information. To manage commands and queries, we will use a library called MediateR. It allows different parts of the app to communicate. The cool part is they don't have to know each other. Let's implement the use case of creating an invoice. Since we need to work with entities, we must reference the domain project. We introduce a createInvoice command class. This command includes the customer ID and invoice items. To make it a request, we mark it with the iRequest interface, and the parameter tells what type of data it should return. Next, we introduce a createInvoice command handler class. The iRequest handler interface makes it a handler for the createInvoice command. To process the command, we need access to the database. But because we want to stay free of technical details, we will rely on abstractions. This gives us flexibility. If we want to change the implementation, we can do so without touching our code. The iCustomer repository interface will help access customer data. It has methods like getAll for retrieving all customers, getById async for fetching a specific customer, the iInvoice repository interface will help manage invoice data. It has methods like add for creating a new invoice, getAll for retrieving all invoices, and an iUnitOfWork property. The iUnitOfWork is a pattern for saving multiple changes as a single unit. It has a commit async method. Now we can use these interfaces in the handler. First, for retrieving a customer based on the ID from the command. Next, we create an invoice for that customer. And finally, we save the invoice using the UnitOfWork. But now we need to retrieve existing invoices. This time we need a query and a handler. The query returns a list of invoice response. We use a data transfer object so we can hide the internal of an invoice. The handler retrieves the list of invoices from the repository, converts each into an invoice response, and then sends the result back. So far, we've built the core of our system, the domain and application layers. Now it's time to take care of the technical details that will support the core. This is where the infrastructure layer comes in. In this project, we are going to provide the implementations for abstractions defined in the application layer. This is where we manage communication with the database, external APIs, authentication services, and file system, amongst many other things. This project depends on the application project, but not the other way around. To keep it simple, we will use an in-memory database with Entity Framework Core. First, we need a DB context class, which we call application DB context. This class has an invoices property to query invoices and a customers property to query customers. Now let's provide implementations for the interfaces. We start with the iUnit of work. However, DB context already supports this through save changes async. So our commit async method simply returns save changes async from the DB context. Next, we introduce the invoice repository, which implements the iInvoice repository. By injecting application DB context, we can implement method required by the interface. Let's do the same with the iCustomer repository. The infrastructure layer is ready. Now it's time to figure out how users interact with our app. This is where the presentation layer comes in. The goal of this layer is to handle inputs from users or external applications. You can build it with a web API, an Azure function, or any UI framework. In this video, we're using a web API. To allow our API to work with commands and query, we add mediate R to the project. Let's add a reference to the application project to enable sending queries and commands. We'll do the same with the infrastructure project to register repositories. Because of this reference, the presentation layer has access to things it doesn't need, like handlers from the application project or repositories from the infrastructure project. So make sure to keep their visibility internal. Let's create an endpoint to add a new invoice. We create a class called Invoice API. First, we add a method called Register Invoice API to set up route for all invoice requests. Next, we set up a post route at /invoices. The endpoint receives a create invoice request object with the new customer's ID and invoice items. Using mediate R, we create a create invoice command with the request data. This command is then sent to the application layer where the invoice creation takes place. We receive a unique ID with the new invoice and respond with a HTTP 201. To retrieve a list of invoices, we start by adding a get route at /invoices. When called, this route uses mediate R to send get invoices query to the application layer. The application layer processes the query and returns the invoice data, which we send back to the client. After creating these endpoints, we'll register them in the program.cs by calling register invoice API. To make sure mediate R can automatically find and use handlers at runtime, we need to register them in the dependency injection container. The same applies to implementing interfaces. First, in the application project, we'll create a class called Dependency Injection with an extension method for the dependency injection container. Inside this method, we will register all the handlers. In the infrastructure project, we will register application DB context to use an in-memory database called InvoiceDB and configure it as the implementation of iUnit of work. We will register customer repository as the implementation for iCustomer repository and invoice repository as the implementation for iInvoice repository. Since our web API project serves as the composition root or the starting point, this is where we will call these extension methods for registration. Instead of having folders for controllers, services, repositories, and so on, we will organize files based on features. In the presentation layer, for instance, everything related to invoices is grouped. The same applies to customers. In the application layer, we will create a main folder for invoices to keep all invoices-related logic together. We will add two subfolders, one for creating invoices and another for retrieving invoices. In the domain layer, Everything related to invoicing will go into a folder named Invoices, and everything related to customers will go into a folder called Customers. Some classes that are shared across features don't belong in a specific feature folder, so they will be placed in a general folder at the root of the project. Let's also organize the infrastructure layer. It may seem like details, but it makes finding and understanding related code so much easier. The API is ready. Let's see it in action. To make testing easier, I've set up a new endpoint that let us retrieve a list of all customers. To ensure we're not starting from a blank slate, I created a DB initializer class in the infrastructure layer. It populates the database with some initial customer data. To add a new invoice, send a post request to /invoices with a payload that includes a customer ID and invoice items. So if everything goes well, you will see a 201 created response. But let's make sure that the invoice made it to the database. We send a GET request to /invoices. So if successful, you will get a 200 OK response with a list of all invoices. With this structure, we've achieved a clear separation of concerns. The domain and application layers are now ready for unit tests, while the infrastructure and presentation layers support integration testing. Because the core of the system, the domain and the application, doesn't depend on details like the UI or database access, it's easy to switch them if necessary. This layering is just one way to organize code, but you can adapt this approach with more or fewer projects as needed. That's it for this video. The source code link is in the description. If you enjoyed this, check out my ASP.NET Core playlist. See you next time.